Do you remember how in my predictions for 2025, I talked about self-developing games? There are two ways to achieve this. One method is generating graphical worlds on the go, like the Genie models from Google do so beautifully. The other is a more programming-focused approach, creating new game levels, or entire worlds, along with the player's progress. Today, we'll do a simple proof of concept for the latter. We're going to create a game where the code is generated on the fly with our progress. Let's begin with something that some of you might find a bit dull. Experiments with the code. If you're more interested in seeing the game in action, feel free to skip ahead to the relevant part of the video. You'll find the links in the description. For our proof of concept, I chose JavaScript because it's the simplest option. While the language itself isn't crucial to the idea, I think it will be easiest to demonstrate it with JavaScript. The first thing I want to check is whether I can access the code. I've set up a script with an identifier that simply logs a message to the console. Later on the page, I define a function to print out this code, and it's triggered when a button is pressed. Let's see if it works. Yes, it works. It gets a bit trickier if the code is in an external file because the content isn't directly visible. However, you can easily download the file using JavaScript. I won't go into that right now since it might sidetrack us, so let's dive straight into the second topic. In our experiment with a self-developing game, it's just as important to be able to connect to the LLM using an API from JavaScript. Let's go over how to do that. I made a small update to our website's code. First, I added a new function to call the LLM as an external file, which I'll show you in just a moment. Also, I changed the button from Show Code to Test the LLM. The button triggers a function in which I define a prompt for the AI. Then I execute the call LLM function with this prompt. Keep in mind that it's an asynchronous function. The response pops up in an alert window. Now let's find out what my AI's favorite island is. We have the answer. It is Santorini in Greece, a picturesque island, part of the Cyclades archipelago. Let's test it again. This time it's Bora Bora. It seems AI is changing its mind. Once more. This time we're jumping from French Polynesia to Hawaii. Maui, without a doubt, is a stunning island too. And we have a completely different climate. Cool and rainy Scotland. Is it a good thing that artificial intelligence changes its mind? Absolutely. Especially when we want the game to evolve on its own, having it go in slightly different directions each time. So the lack of determinism is a big plus for us. If you're interested in learning more about this topic, I highly recommend checking out another video on my channel. It covers models' response determinism in detail, and the various parameters that control this. There is a practical demonstration and an explanation of the theory. It's definitely worth watching. Let's now look at the function call LLM. What might catch your eye right away is that I'm using the GPT OSS model with 20 billion parameters. It's an open source model from OpenAI under the Apache 2.0 license. For communicating with the chat completion API, I use a very simple proxy, which I'll talk about shortly. The communication with the chat completion is straightforward, so I won't go into detail here since I've covered it in previous videos. In the end, the function outputs the model's response in the console and also returns it to the program that called it. Let's quickly check out the proxy. We'll keep it brief since it doesn't add much to the communication. I'm using a proxy for two main reasons. First, to keep the API key out of the JavaScript code so it's not exposed in the browser. And second, to sidestep any communication issues related to same origin policy, CORS, or other security limitations. This approach just makes everything simpler. When it comes to running the OSS model, I use Grok. It is known for its very fast inference process and developer-friendly policy, but you know Grok from my previous videos. But in this video, I want us to concentrate on the concept and nature of self-developing games, rather than focusing on a specific model. since many models now offer exceptional capabilities. But let's make a few small changes to our website to test out code generation with artificial intelligence. The changes are pretty minor. The function to call LM stays the same, but I tweaked the button text a little. But the change in the prompt is crucial. I am asking the model to generate JavaScript code. What's key here is that this code should only run once the start JavaScript function is called, which I've stated explicitly. Also, it's important that only the code is returned but nothing else. Another change is the language model identifier. Note that in this case it calls a 120 billion parameter model, not 20 billion as before. The response is stored in a constant called response. Here's an interesting part. I use the eval function, which takes a string and interprets it as JavaScript. But keep in mind that the script's main functionality hasn't run yet. I've instructed the AI to do this only after I call the start script function, which is what I'll do next. Why do I structure it this way? You'll discover why in the upcoming steps. Let's see if it actually works. According to my prompt, the model should generate a sine wave and balls bouncing off of it. As you can see, everything worked just as we expected. The sine function is animated and the balls bounced off it. The physics might not be ultra realistic since the balls also go up, but let's call this test a complete success. Now I'm going to run the script again to see if we get the same effect. The program is similar but not identical, which is great because we want some unpredictability and slightly different effects each time. Before we move on and finally prepare the first game, I'm running this script once more to see if everything is repeatable and actually works. Yes, it is. The next change in the code will be a bit more significant. Let's take a look at the changes. At the beginning, we have a block of styles, which may not be very interesting in this case. The call LLM function remains unchanged. Next, we have a panel with the score and game level, where I would like us to display this data. Now the really interesting part is just below, and that's the canvas. It's where you can draw anything using JavaScript. I covered this in more detail in the first video about my browser AI agent, so I encourage you to watch it. The key takeaway is that this element exists, and artificial intelligence can interact with it to draw something using JavaScript. Next, we have a button that calls the create game function. Note that aside from a different prompt, the rest of the code does not differ at all from the example with the sine function animation. When it comes to the prompt, I'm asking to create a snake game, and importantly, I'm providing how the scoreboard panel and the canvas element are defined. This way, the AI knows how to refer to these elements in the generated JavaScript code. You know the rest of the routine. We assign the answer to the variable response, then execute the returned JavaScript, and then kick off the start script function. Let's check out how it looks. At the top, we have a panel displaying the scores, just as it was designed. The main section is taken up by the canvas element, which has a black background in this case. Now, I'm pressing the button to generate the game. See how quickly it was generated? Around 2 seconds? Grok is really fast. It must also be admitted that the OSS model is doing quite well. We are already at a stage where open source models can generate flawless code almost every time. As you can see, I can play Snake without any issues. I'm able to collect bonuses, and my score on the scoreboard updates just like it should. Alright, but this is a bit boring game, so maybe let's move on to the next stage and modify the website's code a bit. I made a few minor tweaks. First, I added a text field where you can type in the type of game you want to play. I'm getting value of this field and include its content in the prompt. Everything else stays the same. The model we're using is still GPT 120 billion. I'm opening the developer's tools in the browser to see the console. Now I'm going to test the changes. I'm asking AI to create a clone of the classic game Space Invaders. Request has been sent. Now we're waiting for the results. And here's the outcome, or rather the game itself. It might look like a bunch of rectangles, but the core concept of Space Invaders is still there. As you can see, it's not the most complex game out there, but maybe that's actually a good thing. If someone wants to dig into the code, it should be relatively straightforward. The code shows up in the console because if you remember the call LLM function, there's a line in there that logs what the language model returns. Note that the entire game is wrapped in the start script function because I requested this in my prompt. This allows me to easily control the game from my JavaScript. The code is written pretty clearly and understandably. It's not very long either. However, it's impressive to consider that artificial intelligence was able to create this game in just a few seconds. What if we used a much more advanced model, like GPT-5 or Gemini Pro? But maybe for our purposes, GPT-5-mini will be more than enough. Let's try. I slightly changed the code to use the GPT-5-mini model directly from OpenAI through their API. Of course, the backend had to be slightly modified. But what's really interesting is how our Space Invaders clone is going to look. Will it be nicer than in the case of OSS? GPT-5-mini is a much slower model, so while we're waiting for the game to generate, why not consider subscribing to the channel and giving a like? Since nothing special is happening right now, it's a good time to show your support. I'm even thinking about using some cinema magic to cut out the longer parts where GPT is generating code, just to respect your time. This way, you won't even notice the wait. I want to be upfront about this because it's important when comparing models. But this video is more about the idea of self-developing games than the models themselves. Let's travel in time whenever we can. And magic. As you can see, this time the game is much prettier, at least in my opinion. The aliens, the colors, the ship, and the entire game mechanics are simply more interesting. The game is much more engaging. I think that GPT-5-mini is a good compromise in our experiments, if only we ignore the code generation time. I must say this game really drew me in, just like the old days when we played on arcade machines. But those days are ancient history, even for wizards. And do you remember those times? Or at least played on arcade machines in a museum? I'm feeling a bit nostalgic, so let me finish this level. Let's move on, but before we get to self-developing games, let's try to generate something more. Let's assume that this time it will be another classic game. Classic games hold a special charm, especially for those who have played them before. But wait, I remember Tetris completely differently. This game is more like a clone of Breakout or Arkanoid. Of course, those were great games too, but somewhat completely different. OpenAI, did you ever play those games? Or not? How did you train your models? I sped up this game to show that it totally hooked me and that it really works. Alright, we might have to call this experiment a bust, but it's more on the GPT-5 language model's side, not our idea. Since artificial intelligence can be unpredictable, let's give it another shot. I'm restarting the request. Yes, this time it is what it was supposed to be from the very beginning. Well, I have to admit, the implementation is quite good. The points are counted correctly, and all the features of the game are kept intact. The graphics look pretty fine too. So, this time, I think we can say the OpenAI's model performed well and put the previous mishap behind us. Okay, let's dive into the concept of self-developing games. Here's the idea. As the game evolves, it could adapt based on the player's progress, habits, and actions, generating new levels or worlds in real time. For our simple JavaScript games, we're not talking about creating worlds, but we can imagine our game having levels. Each time we move to a new level, the game's code dynamically expands and evolves. Curious to see how this might work in practice? Let's take a look. Initially, not much changes. At the beginning of the JavaScript code, I define helping variables: level, score, and code, which will later be used to pass certain values. Changes in the game creation prompt are quite significant. I've added conditions for moving on to the next level. I've also included instructions that, when advancing to the next level, The game's JavaScript code should reset timers, global variables, and then trigger the next level function. As you can guess, much more interesting things happen in the next level function. When it is executed, I first delete the existing start script function, because I won't need the previous version of the game, only its code as a reference. I actually treat each level as a kind of separate game. I've crafted a new prompt to inform the artificial intelligence that the player has just moved up to a new level, so we need to set up a new game code, with added obstacles and new graphical features. It indicates the current level, the length of the snake, and that the code from the previous level will be presented as a reference to maintain graphical and logical consistency. This is very important. Similarly to the previous case, I asked to run the next level function later. The code of the first or previous level is always attached at the end. Let's start the game now and see how it works. I asked for the game to be simple, so it is simple. Additionally, to avoid extending the gameplay, I requested a level change after collecting every 3 bonuses. In a real game, it would certainly be more. The code for the next level has been already generated. Some grey dot appeared. Unfortunately, I don't really know what that means. I could have added a request to display information about new game elements. Although, for our presentation, it's not that important. What matters is that the game is developing in some way. Now I am on the 3rd level and this grey dot is moving. It was probably supposed to distract me in some way. It's not the most effective, but let's see what happens next. At this level, I don't really see any difference. Okay, a simple graphic effect was added when collecting the bonus. I probably need to make sure that these changes are more dynamic and that more new things are introduced each level. Now 2 circles have appeared. I'm thinking that it might be worth checking somehow what these elements do. However, I don't want to end the game too quickly because I haven't specified how many lives I have. As you can see on the board, things are really picking up. The game is getting more exciting because the snake is getting longer and moving faster. It seems that the circle is a kind of wormhole. I entered one and exited the other. Please note that each time the snake starts anew. Of course, the program could be modified so that it is always a continuation, but that is not the point of our presentation. This is just a proof of concept. But I would like it to look a bit more attractive and develop more dynamically. Therefore, I will expand the prompts a bit by asking for a more visually appealing game. Alright, let's reset and try again. I made just a few tweaks to the prompts. First, to enhance its appearance, and second, to have more elements show up each time. Let's test this. How do you think? It looks much more appealing now in my opinion. The graphic effects are impressive. Yes, I know, it's still a simple game, but prettier. It's just the 2nd level, and we already have some moving obstacles. At least I think these are obstacles. Yes, I can see a definite difference, even though the prompt was modified only slightly. It's just a few significant words. It's important to point out the consistency with the previous levels. In each prompt, I use the code from the previous level as a reference. It is only expanded, and none of the introduced elements disappear. While the previous game was very boring, I must say that this one is more interesting due to the higher level of difficulty. What's really important for us in this experiment is that first, it works smoothly, and second, there aren't any issues with code generation. Right now, language models are doing it so well that it doesn't need any corrections. Of course, if the code needs to be more complex, you can always run tests before sending it to users. By the way, since progressing through the levels is taking me more and more time, maybe in your free time, click like or subscribe. While you're busy with subscribing, I might speed up the video a bit, so we can move on to the next level. As you might expect, level 6 is even more difficult, so I will speed it up too. And now I'm at the last bonus to collect, success, level 7. More and more fun, but also clearly harder to focus. Okay, almost done. Level 8. I don't know how it looks from the side, but I already have a serious problem locating the bonus on the board, while simultaneously steering the snake. There's so much going on here. I'm thinking that the 8th level might defeat me, and this is a good moment to stop the experiment. I would like us to play with the same prompt once more and see if the game will look different and go in a slightly different direction. Let's try. Oh, what a nice and clear game. But probably because it's the first level. Although for a first level, the snake already moves quite fast, so it will probably get difficult quickly. We can clearly see that the second level looks completely different than in the previous game, so a different development path was chosen. However, as you can see, on the third level we already have a wormhole, which appeared in previous games. But maybe that's because it's really difficult to come up with something completely unique in a snake game, and certain ideas will naturally repeat. For this game, I let the artificial intelligence have free rein during development. If we were working on a more complex game, we could set some boundaries and specific rules to keep the game fair. In our simple example, game development doesn't rely on the player's actions. We've outlined when the game level should increase, and we inform in the prompt about the current level and snake length. However, we could also tailor the prompt based on the player's behavior and preferences. In more complex scenarios, this approach would be beneficial. If we were creating new worlds for an immersive game, we'd likely need to consider what the player enjoys, what they focus on, or what might challenge them. I believe this in the future of game engineering. What are your thoughts on this idea? I'd love it if you could leave a comment below the video. Do you think self-developing games have a future? It might not look exactly like this, but it's the concept that matters. This time in our game it got dark. This significantly complicates finding bonuses. However, I think it looks quite attractive. Alright, but this video isn't about demonstrating my snake playing skills. You've already also seen enough when it comes to game development. It's obvious that with each playthrough, the game evolves and looks different, which was a key part of our proof of concept. We could still consider what the next steps in the development of this idea are. And given that Google has recently released the fantastic NanoBanana model, I could also venture into developing raster graphics on the fly, while the player is exploring the game. However, this episode is already long enough. If there is interest, it would be worthwhile to make a separate video about it. So please leave a comment on what you'd like to see next time. Give a like and subscribe. Thanks for watching. May your games always have perfect code and fantastic playability. See you next time.